Good afternoon, students. So in the last class, we have seen the problems related to specific gravity and Voigt's ratio. So I am sharing the screen. I hope it is visible to you. I hope it is visible to you. The discharge of water collected from a constant at permeameter in period of 50 minutes is 400 ml. Hello, students. बोलिए, यहाँ आप जरा अंदर था विजिलेंस करो. हम्म. हम्म. अच्छा. इससे पहले दिए थे बोल बोल रहे थे काशिफ फोन करे थे. अब ये लोग करते बैठे ना, हम हमारे बात करते. खाली फैन निकाला ना. ठीक ठीक. The discharge of water collected from a constant head perimeter in period of 15 minutes is 400 ml. The internal diameter of the perimeter is 6 centimeter and measure in heads between two gauging points 15 centimeter apart is 40 centimeter. Calculate the coefficient of permeability. If dry weight of the 15 centimeter long circle is 7 Newton and the specific gravity of the solids is 2.65. Calculate the seepage velocity. So capital Q is how much? 400 ml. Small d is 51 to 60 comes out of 900 seconds. Pi is equal to 6 centimeter, h is equal to 40 centimeter, d is equal to 15 centimeter, k is you need to calculate. So your k is equal to ql by ath. Q is 400 into 15 divided by pi by 4 into 6 square into 900 into 40. It comes out to be 0.005893 centimeter per second. So your V is equal to Q by T into A. Q is 400, T is how much? 900, A is pi by 4 into 6 square. So it comes out to be 0.0157. P is 0.0157 centimeter per second. So the next problem is in a consolidation test, the voids ratio of the soil sample decreases from 1.2 to 1.1 when the pressure is increased from 160 to 320 kilonewton per meter square. Calculate the coefficient of consolidation. Give the coefficient of probability is 8 into 10 raised to minus 7 mm per second. So E1 is equal to 0.2, P1 is equal to 160 kilonewton per meter square. A2 is equal to 1.10, A2 equal to 320 kilonewton per meter square. So here MB is equal to AB by 1 plus E1, that is equal to delta E divided by delta P divided by 1 plus E1. So it comes out to be 1.0 minus 1.11 divided by 320 minus 160 divided by 1 plus 1.0, where MB comes out to be 1.375 into 10 raised to minus 3 meter square per kiloliter. So your K is equal to CV into MV gamma W. CV is equal to K divided by MV into gamma W. So CV is equal to K is how much? 8 into 10 raised to minus 10. MV is 1.375 into 10 raised to minus 3 into 9.8. So your CV comes out to be 5.93 to 10 raised to minus 8 meter square per second. And M comes out to be 1.375 to 10 raised to minus 3 meter square per kilonewton. The next problem is water curve fitting methods used in consolidation test. Explain any one. So the different curve methods used in consolidation test are square root of time fitting method, logarithm of time fitting method. So square root of time fitting method. This method consists of drawing the curve between root of time under root t and abscissa and dial reading are representing the compression of the specimen as ordinate for any pressure increment in the consolidation test. Initial dial reading R naught corresponds to the time t equal to 0, b equal to 0. The straight portion is produced back to get the ordinate at readings RC, which is called the corrected zero reading, and the consolidation between R naught and RC is called initial consolidation. So square root of time fitting method consists of this method consists of drawing the curve between the root of time root T has abscissa and dial range reading R, representing the compression of the specimen as ordinate for any pressure increment in the consolidation test. Initial dial reading R naught corresponds to the time T equal to 0 and B equal to 0. The split portion is produced back with the ordinate at reading RC, which is called the corrected zero reading, and the consolidation test between R naught and RC is called initial consolidation. From RC, draw another line B such that its abscissa at every point is 1.15 times that of line A. Intersection of the B with the consolidation curve gives a point P corresponds to 90%. U, whose dial reading and time may be designated as R0 and T respectively. From the curve, we get rho T naught T equal to 5.5 or T net is equal to 5.5 square. Coefficient of consolidation can be calculated as CV equal to TV into D square, V90. So explain Moore Coulomb's theory for shear strength of soil. Moore Coulomb's failure theory. So this theory is based on the assumption that a relationship exists between shear strength and normal stress can be represented by a straight line. Moore's theory also states that shear strength depends on the normal strength, but it emphasizes that it is not a linear relationship. So what is Moore Coulomb's failure theory? It is in this way. Coulomb's envelope, Moore's envelope. This is C. So however, from both Moore and Coulomb concept, it is concluded that the Moore's Coulomb envelopes can be considered to be a straight line if the angle of internal friction phi is assumed to be constant. Depending upon the properties of the material, the failure envelope may be straight or curved and it may pass through the origin of stress. Next question. How do you classify the shear stress based on drainage condition? So drainage is not permitted at any stage of the test, hence no time is allowed for dissipation of one water, pressure and concentration. Also no significant volume change is expected. Usually 5 to 10 minutes may be adequate. Undrained tests are often performed only on soils of low permeability. Consolidated undrained test. Drainage is permitted during the application of normal stress and no drainage is permitted during the application of shear stress. Volume changes do not take place during shear and excess pore pressure or develops. After the soil is consolidated under the normal stress to the desired degree, 5 to 10 minutes may be adequate for the test. Drain test or in a slow test. Drainage is permitted fully before and during the test. Now, no excess pore water pressure develops at any stage. Volume change takes place. It may require 3 to 6 weeks to complete a single test on a cohesive salt tile. So this completes our preparation for the exam. I will just recall the things. You just see it from the start. It all started with module 1, where we studied what we mean by three-phase system. So soil is considered to be three-phase system consisting of water, air, and gas, water, air, and solids. So the volume, total volume V is equal to VA plus VW plus VS. Next was turbine limits. Gutenberg divided the soil into 4 stages: liquid state, plastic state, semi-solid state, and the solid state. Atterberg set the arbitrary limits for these 4 stages as consistency limit of Arabic limits. To define bulk density and dry density of soil. So bulk density of soil is nothing but ratio of mass of soil to volume of soil and the SI unit is kg per meter. Dry density of soil is L dry mass of soil to volume of soil. MD by L. SI unit is kg per meter cube. Define water content and voice ratio. Water content W is equal to WW by WD into 100 and voice ratio E is equal to VV by VS. Define specific gravity and unit weight of soil. The specific gravity of soil G is gamma S by gamma W and unit weight of soil is gamma S is equal to WD by VS. Then density index is nothing but defined as ratio of difference between the voids of the soil in its loose state and its natural voids ratio to the difference between the voids ratio in the loose and dense state. Module 2. Define honeycomb and flocklet structure. Honeycomb is an arrangement of soil particles having comparatively loose, stable structure, resembling a honeycomb. An arrangement composed of flocks of soil particles instead of individual soil particles and flocklet structure. So, what do you mean? So, Kalionite. So, kaolin structure unit is made up of gibbsite sheets joined to silica sheets through the unbalanced oxygen atoms at the apex of the slices. Montmorillonite is the most common clay mineral in expensive soil, clay soils. The mineral is made of sheet-like units. So, what is compaction? Compaction is a process in which the soil particles are artificially rearranged and packed together into a closer state of contact by mechanical means in order to decrease the porosity of the soil and thus increase its dry density. So, what are the factors affecting compaction? Factors affecting compaction are water content, amount and type of compaction, type of soil, addition of admixture. Define zero airworks line, a line which shows the water content dry density relation for the compaction cell containing a constant percentage. Airworks is known as your zero airworks line. So differentiate between disperse and coarse grain skeleton structure. Disperse is an arrangement composed of particles having face-to-face or parallel orientation. Whereas coarse grain skeleton is an arrangement of coarse grain forming a skeleton with its intersects particularly filled by relatively loose aggregation of finer soil. So what is Darcy's law? Darcy's law states that the rate of flow or discharge per unit time is proportional to hydraulic gradient in the laminar flow condition in a saturated soil. So how you differentiate superficial velocity and coefficient of percolation? Superficial velocity V equal to Q by A. Coefficient of percolation is the seepage velocity is proportional to the hydral rate. Define permeability and coefficient of permeability. So how you will define permeability? Permeability is defined as seepage of water to soil coefficient of permeability. Permeability is defined as seepage of water of soil. Whereas coefficient of permeability is defined as average velocity of flow that will occur through the total cross-section area of the soil under hydraulic gradient. Discharge, define discharge velocity, seepage velocity. So discharge velocity V equal to Q by A, where seepage velocity V is equal to Q by A. So what are the factors affecting permeability? The factors affecting permeability are grain size, properties of pore fluid, voids ratio of the soil, structural arrangement of soil particles. So define shear strength of soil. How you will define shear strength of soil? Shear strength of soil is the resistance to deformation by continuous shear displacement of soil particles by the action of shear stress. So, how you will define shear strength of soil? Shear strength of soil is the resistance to deformation by continuous shear displacement of soil particles by the action of shear stress. Define thixotrophy and sensitivity. The phenomena of strength loss or strength gain. It may be either of the two. Either there will be a loss of strength or there will be gain of strength. With no change in volume or water is known as your thixotrophy. Next, sensitivity. How you define sensitivity? Sensitivity is the ratio of unconfined compression test in the natural or undisturbed state to that in remolded state without changing water content. So how we are defining thixotrophy and sensitivity? The phenomena of strength loss or strength gain with no change in volume or water is known as thixotrophy, where sensitivity is the ratio of unconfined compression strength in the natural and steps state to that in remodeling without changing water content. So what are the factors affecting shear strength of soil? Soil composition, initial state and structure. So what are the laboratory methods used to promote shear strength of soil? Direct shear test, triaxial shear test, unconfined compression test, well shear test. What are the different types of shear test based on drainage condition? Undrained test or pit test, consolidated undrained test, and drain test. Next, what do you mean by consolidation? The compression resulting from a long-term static load and the consequent escape of pore water is known as a consolidation. So, how we are defining consolidation? As a compression should be result from long-term static load and the consequent escape of pore water is known as a consolidation. What are the assumptions made in release theory? The assumption made in release theory are the soil is homogeneous and fully saturated. The soil particles of water are incompressible. What are the assumptions made in release theory? If the soil is homogeneous and fully saturated, then the soil particles of water are incompressible. Right? Coefficient of compressibility AY is equal to minus delta E by delta sigma. Whereas coefficient of volume change MP is defined as change in volume of soil per unit of initial volume due to given unit increase in the pressure. So what are the methods to determine consolidation settlement? Consolidation settlement can be completed with two methods using coefficient of volume change MV. Next method is using voids ratio. Define primary and secondary consolidation to the reduction in volume of soil, which is due to squeezing out of water from water is for primary consolidation. Whereas secondary consolidation, how you define the reduction of all excess hydrostatic pressure to zero some compression of soil. It's very slow is called secondary consolidation. Next is with the help of three-phase diagram, define the following terms: air content, relative density, dry density, and saturated density. So how you define air content? Air content is defined as volume of air voids to the total volume of voids. So how we are defining air voids? It is defined as volume of air voids to the total volume of voids. Next, relative density. It is the ratio of difference between the voids ratio of cohesion less soil in its loose state and existing natural state. The difference between Schwartz ratio and the loose consisted. So what is dry density? The dry density is the mass of solid per unit of total volume before drawing of the soil mass, or would be equal to MD by V. Saturated density. So how you define saturated density? It is defined as the ratio of total soil mass of saturated sample to its total volume. So with usual notation, you need to prove S equal to WG. So S is equal to WG or S equal to WG by 7 or E into that. Okay. So SE equal to WG, E equal to WG by SR, or E into SR is equal to WG. For fully saturated soil, SR is equal to 1. E is equal to VV by VS, or this VV by VS is how much? Because G specific gravity is WS by VS into gamma W. Therefore, V is equal to WS W plus R divided by G into gamma W. So your Vs will be W into SR divided by G into gamma W. So your E is equal to G into VV by WS into WW by VW. Or your E is equal to G into VW by VW into WW by WS. Or water content is weight of water by weight of solids. Similarly, specific gravity is volume of water by volume of voids. Sorry, degree of saturation is volume of water by volume of voids. So your E will be equal to WG divided by S, or S equal to WG. Gamma D is equal to 1 minus delta I into G into gamma W divided by 1 plus WG. So from the three-phase diagram or system, we have V is equal to VA plus VW plus VS. So dividing throughout by V, what you will get? V by V equal to VA by V plus VW by V plus VS by V. So VA by V equal to neta A, or 1 is equal to neta A plus VW by V plus VS by V, or 1 minus neta is equal to VW by V plus VS by V, or 1 minus neta is equal to WW by gamma W by V plus WS divided by G into gamma WV, because G is equal to WS divided gamma S into gamma W. Therefore, here VS is equal to WS by G gamma W, or VW is equal to WW by gamma W. Water content is nothing but ratio of WW by WS, or WW is equal to W into WS. So 1 minus theta is equal to W into WS, gamma W into V plus WS by G into gamma W into V. So your gamma D is equal to weight of dry cell by volume equal to WA plus WS by V equal to WS by V. Now substituting gamma D value in equation 1, 1 minus theta equal to W into gamma D by gamma W plus gamma D by G gamma W. So 1 minus theta equal to G into W gamma D plus gamma D. So gamma D you can take common 1 plus WG divided by G gamma W. So here 1 minus theta into G into gamma W is equal to gamma D into 1 plus gamma. So your gamma D is equal to 1 minus theta G gamma W divided by 1 plus WG. So now we will solve a problem on this. In its natural condition, a soil sample has a mass of 22.9 Newton and a volume of 1.1 into 10 raised to minus 3 meter cube. After being completely dried in the oven sample, weighing 20.35 Newton. So what you need to calculate? Find the bulk density, water content, voids ratio, degree of saturation, air content, dry density, and percentage air voids. These five things you need to calculate. So mass of soil in its natural condition M 20 22.9 Newton 22.9 divided by 1000. It comes out to be 0.0229 kilonewton. Mass of dry soil sample MD is equal to 50.35 Newton. So here MD is equal to 50.35 divided by 1000. So it comes out to be 0.0203 kilonewton. Volume B is equal to 1.15 into 10 raised to minus 3 meter cube. Meaning specific gravity G is equal to 2.7. Bulk density gamma B is equal to M by V. M is equal to 0.0229 divided by 1.15 to 10 raised to minus 3. So gamma B is equal to 19.9130 kilonewton per meter cube. So the water content W is equal to M minus MD divided by MD. So your W is equal to 0.128 or 12.807%. Dry density gamma D is equal to gamma B by 1 plus W. So your gamma D comes out to 17.6533 kilonewton. Voice ratio equal to G gamma W by gamma D minus 1. 2.7 into 9.8 divided into 17.653 minus 1. Your E comes out to be 0.499988. Degree of saturation SR is equal to WG by E. So your SR is equal to W nothing but 0.128 into G is 2.7 divided by E is 0.4988. So your SR comes out to be 0.6928 or 69.8%. Air content AC is equal to 1 minus S. 1 minus S is 0.692 So your AC comes out to be 0.3072 or 30.72%. Percentage air voids delta A. Gamma D equal to 1 minus delta into G gamma W divided by 1 plus delta G. So gamma D is 17.6533 equal to 1 minus theta into G is 2.7 into 9.8. 1 plus W is 0.12 into 2.7. So if you do the calculation, it comes out to 17.6533. So your 1 minus theta is equal to 1.1127. 1 theta equal to 1.1127 minus 1. Or your theta comes out to be 0.1127. So this is nothing but what you can say the answer for theta. Next is we need to understand what you mean by briefly explain common clay minerals in soil and their structures. So this is a bit of new answer. This we will see in the next class. I hope you are understanding the concept. If you are having any doubt, you can just drop a message in the comment box, or you can just drop a message, or you can mail me at anybody@km.university. Even you can call me at 8553171859 and during evening hours. So in this class, we will wind up here only. In the next class, we will continue the things. Thank you.